I hope that was the right page. Okay. So looking at the study guide, I am assessing your skills on the following. Those are your learning targets or your power standards for this whole unit. So evaluate and conduct mole calculations. Use balanced chemical equations to predict specified amounts of products and reactions. That's going to be like making your theoretical yield. Determine percent yield and determining limiting reagent for real-life chemical reactions. If you are in the back of the room and you're having a hard time seeing, you also can join the Google Meet so that you can see my screen better. So you've got a few different options for sight today. Number 1 says calculate the number of moles and the mass of chlorine, Cl2, required to react with 10 grams of sodium metal to produce sodium chloride. So the question is asking for two different things. It wants number of moles and it wants the mass of chlorine. So we've got a want 1 and a want 2. Two different wants for this one. So two different questions embedded in this problem. And it gives you a given. What is the given in this problem? Yeah, grams of sodium. Our given is grams of sodium. So we've got 10 grams of sodium metal. So we're going to take our 10 grams of sodium metal. Sweet. 10 grams of sodium. And first I'm going to calculate it to moles. So looking at my flow chart. How do I go from grams to moles? What's my first step if my starting point is grams? Divide by the molar mass. So we have to figure out what the molar mass of sodium is. If you look at your periodic table, sodium is over here. Sodium is 22.99. So we're going to take 10 and we're going to divide it by 22.99 grams per mole. Next, I want chlorine. So next I have my what ratio? What's this called? What kind of ratio is this called? The mole ratio, coefficient want over coefficient given. All right, we want chlorine. So looking at our equation, chlorine has a 1 in front of it. So 1 Cl2. We were given sodium. Sodium has a 2 in front of it. So 2 Na. The first problem just asked for moles. So we're just going to leave it there because moles doesn't involve any of these three calculations off to the side. So we're going to calculate our number of moles. So 10 times 1 divided by 22.99 times 2. That's camera, not what I wanted. Here we go. 10 divided by 22.99. You should get 0.217. What's my unit for that? Moles of Cl2. So there's one answer. The question also asked for the mass of chlorine. So all we need to do to solve for the mass of chlorine is we're going to keep our same train tracks. 10 grams of sodium over the molar mass of sodium times our mole ratio. But this time we want grams, and we want grams of Cl2. So we need to, up top here, because we want grams, we're going to multiply times the molar mass of what we want. And what we want is Cl2. That is 70.9. So when you multiply that times 70.9, you end up getting an answer of 15.42. And that's going to be grams of Cl2. Number 2 says calculate the number of moles and the mass of oxygen formed by the decomposition of 1.252 grams of mercury oxide. Reading that question, I have two wants. Number of moles and mass of oxygen. So we want the number of moles of oxygen and the mass of oxygen. So O2 is going to be our want. This question also has a given. Our given in this question is 1.25 grams of mercury oxide, and That is mercury oxide right there, highlighted in pink. So we'll start with our mole calculation first, and then we'll add on to it. And I think I left you guys room to write that down here. So we're going to start with 1.252 grams of HGO. When I start with grams, what goes underneath my grams? The molar mass of my given. So in this instance, I've got to figure out the molar mass of HGO. Mercury has a molar mass of 200.59, right down here, 200.59. Oxygen has a molar mass of 16. So I'm going to take 200.59 plus 16, and that gives us 216.59. I want O2. What coefficient is in front of O2? 1. I'm given HGO. What coefficient is in front of HGO? 2. All right, so to solve for moles, this is all we're going to do for moles, okay? 1.252 divided by 216.59 times 2. And I get 0.00289, so we're just going to say roughly 0.003 moles. It's really, if you want to know the actual number, that's the actual number, if you wanted that. All right, I also want the mass of oxygen. So what's the last step I need to do to get the mass of oxygen? Multiply by the molar mass of what I want. The molar mass of what I want, oxygen is what I want. O2, 2 times 16 is 32. So we multiply that by 32. And I get 0.092 grams of oxygen. Number 3 says, given the following reaction, Na2S2O3 plus AgBr becomes NaBr, and then plus Na3 AgS2O32. Jesus. All right. Looking at this equation, my first question I have for you is it balanced? What? No, it's not balanced. In order to get it balanced, it's pretty quick and easy. What do I need to do? If I add a 2 in front of Na2S2O3, if I add a 2 there, now I have 4 sodiums. I have 1 sodium over here plus 3, so 1 plus 3 is 4. So 4 and 4, is that balanced? Yes. All right. S2O3, if we just look at that as its own entire unit, I have 2 of those. And if you see over here, I have how many of them? 2 of them. Is that balanced? Yes. Ag, I have 1. Over here, I have 1. Is that balanced? Br, I have 1 on the left. I have 1 on the right. Is that balanced? So the 2 balances that bad boy out. A says how many moles of Na2S2O3 are needed to react completely with 42.7 grams of AgBr. So this has a question in it. It wants to know moles of Na2SO3. Okay, it wants to know moles of that. Na2SO3, which I'm just going to highlight in blue right here. It gave to us 42.7 grams of AgBr. So we have our want, we have our given figured out. Next, we just have to plug and chug. So 42.7 grams of AgBr. What needs to go underneath AgBr. Molar mass of AgBr. I'm going to give you guys a second to work with the people at your table to finish out this problem. Work with the people at your table. So you know the molar mass of AgBr goes under here. I want you guys to work together to see if you can finish out the rest of what the question is asking for. What's my molar mass of AgBr? 187 point what? 74? Cool. We'll go with 187.7. All right. This one wants moles. So I need my want over my given. I want Na2S2O3. There's a 2 in front of that. And I was given AgBr. So 42.7 times 2 divided by 187.77. That is right. 0.45 moles. Na2S2O3. How do we do? Yeah. Yeah, because I didn't have a question balanced on the thing. That's why. And that's why I made sure we balanced it when we sat down. So this is the answer you should have gotten. Sorry. All right, letter B. What is the mass of NABR that will be produced from 42.7 grams of AgBr? If you already have this in your calculator, do you need to reset up the train tracks technically? No, what would you just need to multiply the number in your calculator by? The molar mass of NABR. However, it wants NABR in this problem. So yes, we are going to have to do some math. We're going to take 42.7 grams of AgBr over 187.77. In this problem, we want NABR. And it wants the mass of NABR. What's my coefficient in front of NABR? 1. What's my coefficient in front of AgBr? 1. Lastly, I need to multiply by what? The molar mass of NABR. Molar mass of NABR is 102.89. So we're going to take 42.7 times 102.89 and divide it by 187.7. And I got 23.39. Is that what you guys got? Your unit is going to be grams of NABR. All right, any questions on 1 through 3? Looking at question 4, I would like you guys to take a minute and discuss with your tables whether you think that's balanced or not. If it is balanced, then just hang tight. If it's not balanced, try to balance it. So very clearly it's not balanced, right? We need to figure out how to balance it. So first let's do our counts. On the left side, we have 2 B's. We have 6 H's and 2 O's. On the right side, we have 3 H's. We have 1 B and we have 3 O's. I think one of the most simple things to start with is to look at boron. Look at that B. We want to change that from a 2 on the left to a 2 on the right. So we're going to throw a 2 right here. And when we do that, we now have 2 borons. 2 times 2 is for oxygen. It puts that oxygen at a 4 plus that one is 5. 2 H's here plus those 2 is 4 H's. Boron is set. Hydrogen and oxygen are not. What is something I could do to try to change my hydrogen and oxygen count? I want to change my hydrogen and oxygen count on the right side. I've already changed HbO2. Could I put something in front of H2O? What could I put there? A 2. Okay, so let's put a 2 there. That's going to make how many hydrogens in H2O? 2 times 2 is 4. Plus the 4, or sorry, the 2 over here. So 4 plus 2 is how many? 6. 2 times 1 is 2. 2 plus 4 is how many oxygen? 6. 2 and 2, 6 and 6, 2 and 6. Could I make this 2 a 6? What would I need to do? Put a 3 in front of O2. And now we're balanced. So our numbers would be a 1 in front of B2H6, a 3 in front of O2, a 2 in front of HbO2, and a 2 in front of H2O. Now we can move forward with our question. Letter A wants to know what mass of O2. So mass of O2 is going to be our what? Want or given? Mass of O2. It's your want. Very good. All right. Mass of O2 is our want. And we're given 36.1 grams of B2H6. That is our given. So we're going to take 36.1 grams of B2H6. What do we need to divide that by? Molar mass. We have to figure out the molar mass of B2H6. 6 hydrogen means that we have 6.06 there. Boron has a molar mass of 10.81. So 10.81 times 2 plus 6.06 gives us 27.68. I want oxygen, so what should go up top for my coefficient? 3. 302, because we just balanced this with a 3 in front of it. What should go underneath 302? 1 B2 H6. Lastly, I want mass of O2. So what's my very last step if I want mass of O2? Not divide by, multiply by. Very good. We're going to multiply by the molar mass of what we want. We want O2. So 2 times 16 is 32. So 36.1 times 3 times 32 divided by 27.68. Yep. And I got 125.2. Questions on that one? All right, let's look at the next question. Letter B. It says, how many moles of water are produced from 19.2 grams of B2H6? I want water. I'm given B2H6. So 19.2 grams of B2H6 divided by the molar mass, which we calculated right up above, so you can just kind of steal that from there. We want water this time. What's my coefficient in front of water? 2. And what's my coefficient in front of B2H6? 1. Do I need to do anything else if I'm solving for moles? Is there anything else I need to do here? Do I need to do any of these 3 if I'm solving for moles? I don't need to multiply by molar mass. I'm not trying to get to grams. I'm not trying to get to liters, and I'm not trying to get to particles. So I just let it be. So 19.2 times 2 divided by 27.68. 1.39. And that's going to be moles of H2O. All right, I'm going to pause this for a second. All right, so we're going to jump around. We're going to do number 8 really quick. Number 8 reads, if 28 grams of N2 and 25 grams of H2 are reacted together, which one would be the limiting reactant? And it also has a little hint in there, is the question balanced? So the first thing you need to look at, is this equation balanced? N2H2 becomes NH3. If we look at this, we've got 2 nitrogen, 1 nitrogen, 2 hydrogen, 3 hydrogen. Is that balanced? No. In order to balance it, what if I put a 2 here? Now I have 2 nitrogen and 6 hydrogen. What do I need to do to balance out hydrogen? A 3 here. Are we balanced? Now we're balanced. All right. 28 grams of N2 and 25 grams of H2. Let's look at these two numbers. 28 grams of N2. Is that a reactant or a product? Reactant. 25 grams of H2. Is that a reactant or a product? Reactant. Even though the question already said what is the limiting reactant, this is another one to practice figuring out if it's limiting reactant or not. We're given 2 reactants, so that is an indicator that this is a limiting reactant problem. It says which one will be the limiting reactant? Does it specify that I need to solve for NH3? No, but do I have another option? No other option. So NH3 is what I'm going to solve for. So we're going to have 2 train tracks going on here. We're going to start with 28 grams of N2 and 25 grams of H2. I'm starting with grams. What do I need to do for both of these since I'm starting with grams? Divide by the molar mass of my given. So N2, nitrogen, has a molar mass of 14.01. So 14.01 times 2 is 28.02. Hydrogen has a molar mass of 1.01. So 2 times 1.01 is 2.01. Or sorry, 2.02. Next, I have my mole ratio. I want NH3. What's in front of NH3 in my balanced equation? 2. This one gave me N2. What's in front of N2? 1. Looking at my bottom one, we still want NH3, so I'm going to keep that 2 NH3 up top. But my given is different here. My given is H2. In front of H2, there is a 3. All right, so 28 times 2 divided by 28 gives us 1.99 moles of NH3. 50 divided by 6.06 is 8.25. So comparing these two numbers, which one's smaller, my top or my bottom? Top is smaller, which means what is my limiting reactant? Hydrogen or nitrogen? Nitrogen. 28 grams of nitrogen is my limiting reactant. So that's your answer for that one. And that was number 8. Okay, so number 11. Chlorobenzene, which is C6H5Cl, is used in the production of chemicals such as aspirin and dyes. One way that chlorobenzene is prepared by the reaction of benzene, C6H6, with chlorine gas according to the balanced chemical equation. I messed up. This plus H6 liquid should not be there. It should just be C6H6 plus Cl2. That was a boo-boo on my part. I got a little type happy. And now if you actually look at it, it is balanced now. Before, when that H2 was in there, it was not right. But now it is right. So if you look at this equation, 6 carbon, 6 carbon, 6 hydrogen, 5 plus 1 is 6 hydrogen. Cl2, 1 plus 1 is 2. So it is balanced right there. Bye. Letter A wants to know, what is the theoretical yield of 45.6 grams of benzene reacting? Benzene is C6H6. So 45.6 grams of benzene. Okay, it says, what is the theoretical yield? But necessarily it's not specifying which theoretical yield I'm supposed to solve for. Reading this question, how can I figure out which one I really am trying to solve theoretically for? What if you read letter B? Letter B might tell you what one we're looking at. Do you guys see it? Chlorobenzene is what we're solving for. So we're going to try to find the theoretical yield of chlorobenzene. And the reason I know that is because my actual yield was given to me of chlorobenzene in letter B. So sometimes you have to, when you have multiple step questions like this, it is smart to kind of read ahead. So we're going to take 45.6 grams of benzene, and we need to do what with it? Divide by the molar mass. 12.01 times 6 plus 6.06 gives us 78.12. So our molar mass is 78.12 for our benzene. I want chlorobenzene. What's my coefficient in front of chlorobenzene? What's in front of this? 1. All right. I'm given benzene, C6H6. What's in front of benzene? 1. Lastly, I want the molar mass of chlorobenzene. So 12.01 times 6 plus 5.05 plus 35.45 will give us 112.56 grams per mole. These numbers? I calculated the molar mass of this. So 6 times the molar mass of carbon. Carbon is 12.01. So 6 times that, plus 5 times hydrogen, which is 1.01, plus Cl, which is 35.45. Okay. And that gave you 112.56. 45.6 times 112.56 divided by 78.12 gives me 65.7. Is that what I gave you guys? Our unit is going to be grams, and that's going to be grams of chlorobenzene. So that is our theoretical yield, 65.7 grams of chlorobenzene. B said your actual yield is 63.7. It wants you to calculate percent yield. So our calculation for percent yield is actual over theoretical times 100. So my actual is 63.7. My theoretical is 65.7. I'm going to multiply that times 100. And I get 96.95 well, actually 96.96. And that is going to be a percent. All right, so going back to number 5, what mass of hydrogen peroxide must decompose to make 0.241 grams of water? This is a nice one. This is a mass to mass conversion. So looking at our little flow chart, we're going to take grams of our given, divide it by the molar mass, multiply by our coefficient ratio, and then multiply by the molar mass of what we want for this one. So our given is 0.241 grams of water. We're going to divide by the molar mass of water. So this is one of those molar masses that eventually is going to just become part of your brain because it has for me. So 18.02 is what the molar mass of water is. It's just one you kind of get used to seeing a lot. We want hydrogen peroxide, so there's a 2 in front of H2O2. We're given water, there's a 2 in front of H2O. So thankfully our mole ratio just kind of cancels itself out. And lastly, we want the molar mass of H2O2. So 32 plus 2.02 gives us 34.04 as our molar mass of, 34.02 as our molar mass of hydrogen peroxide. After you calculate this all out, I ended up getting 0.45 grams of H2O2. Is that what we got as well? For those of us who did it? Yeah? I'll post the video for you guys too. All right. Number 6. Number 6 is a little different from what we've seen so far. We've got 2.66 liters of carbon dioxide, so CO2. And it wants to know the mass of benzene in this reaction. Benzene is going to be the thing that you don't recognize in this problem because we know O2, we know H2O, we don't necessarily know C6H6. So mass of benzene is what we're solving for, and that's that C6H6. My given is 2.66 liters of carbon dioxide. My want is benzene. Go ahead and fill in your train tracks for this one to start. All right, 2.66, that's my given. Where does that go in my train tracks? Top left. Very good. So 2.66 liters goes in the top left. We're given liters. What goes underneath liters in our flow chart? 22.4 is correct. 22.4 liters. I want the mass of benzene. Benzene's the C6H6. So does benzene go on top or on bottom? On top. So my 2 C6H6 goes up top. My 12 carbon dioxide goes down low. Lastly, I'm going to multiply times my molar mass of benzene. 12.01 times 6 plus 6.06 gives us 78.12. Is this kind of what your guys' look like or what it was starting to look like? All right, so we're going to take 2.66 times 2 times 78.12. And we're going to divide that by 22.4 times 12. And I get 1.55. Is that what the rest of us got? And our unit is obviously going to be grams, and that's going to be grams of C6H6. All right, number 7 is going from liters to molecules. So number 7, we've got 2.63 liters of oxygen, so 5 oxygen, are consumed in the combustion of acetylene. How many molecules of carbon dioxide should be produced? We are trying to figure out molecules of CO2. Do I need to do any molar mass calculations in this problem if I'm going from volume to molecules? I'm going from volume, liters. Yeah, but no molar masses for these ones. That's why I like these. They go quicker. So we're going to take 2.63 liters. Since we're starting with liters, if you look at your flow chart, we are going to divide by 22.4. So 22.4 goes down below. Next, we have our mole ratio. We want CO2. So 4 CO2 goes up top. We were given O2, so 5 O2 goes down below. That's from our coefficients. And lastly, we want molecules of CO2. In order to get to molecules, we're going to multiply times Avogadro's number. I want to show you guys how to do this one on Desmos because that's the calculator I'm going to be making available to you guys tomorrow. I want to make sure we all know how to calculate on Desmos. All right, so for this top part, I already have my 2.63 and my 4 typed in there. I want to multiply times 10 to the 23rd power. So I'm going to get my times 10. I'm going to hit this AB button. Do we all see this right here? This AB button? So times 10, and we're going to get 23rd, and then close our parenthesis. And then we're going to divide that and start a new parenthesis. We're going to divide that by 22.4 times 5. And then your number is right here, 5.65 times 10 to the 22nd. You need that times 10 to the 22nd in your final answer. Okay, so 5.65 times 10 to the 22nd. Units will be molecules of what? You guys are rock stars. Are we feeling good? Feeling a lot better? Maybe? Okay. All right. Number 9. Another limiting reactant problem, but also we have to check to make sure our equation is balanced, and it's not. So we have C3H8 plus O2 becomes H2O and CO2, another combustion reaction. We have carbon, hydrogen, and oxygen as our 3 elements. On the left side, I have 3 carbon, I have 8 hydrogen, and I have 2 oxygen. On the right, I have 1 carbon, I have 2 hydrogen, and I have 3 oxygen, and the oxygen split up in 2 different places. I think the easiest thing is to first get that carbon balance, so I'm going to put a 3 in front of CO2. When I put a 3 there, I now have 3 carbon. 3 times 2 is what? 6. So underneath this oxygen, I'm just going to write a 6 as a reminder to me that I have 6 oxygen there. But I also have another oxygen in water. So what is 6 plus this oxygen? 7. Very good. All right. I have 8 carbon on the left. I have 2 on the right. How could I change the 2 on the right? What could I put in front of that? A 4. So if I put a 4 in front of that, I now have 8 carbon. 4 times 1 is 4 oxygen. 4 plus 6 is 10 oxygen in total. And I can get this 2 to a 10 really easily by putting a 5 out front here. And I now have 3 and 3, 8 and 8, and 10 and 10. Do we all see that? Amazing. Okay. We've got 28 grams of C3H8 and 45 grams of O2. It wants to know which one is the LR. Doesn't matter which product I use. No. Now, could I make my life easy by reading ahead and seeing what any other problems might ask for? Okay. Reading ahead. Using the above problem, how much CO2 will be made? Would it be the smartest to solve for CO2? Probably, because it's going to be less work for number 10. Does it matter which one you do? Absolutely not. Okay? I'm just showing you how to work smarter, not harder. That's all. Okay, so we're going to take our 28 grams of C3H8 and 45 grams of O2. Molar mass of C3H8. 44.01 or 44.1 is what this is. Yeah, it's actually 0.11. There we go. Boom. 44.11. So we got both of our molar masses underneath our masses. We are going to solve for CO2. That's what we agreed upon. So we're going to solve for this CO2 over here, just because that's going to help us with this problem later on. Okay, so that's why I chose to solve for that one. So what's my coefficient in front of CO2? 3. All right. Coefficient in front of propane, C3H8. 1. Coefficient in front of O2? 5. All right. Do I need to go any further when I'm just solving for LR? No. Could I go further? Yeah, what could I do to help to make my math easy for number 10? I could put the molar mass of CO2 in here and solve this for grams of CO2, but you don't need to, and we're not going to, because you'll just do it afterwards. So 28 times 3 divided by 44.11 gives us 1.90 moles of CO2. And 45 times 3 divided by 32 times 5 gives us 0.84 moles of CO2. So how many moles of CO2 am I really going to make? Am I going to make the 1.9 or the 0.84? We're going to make the 0.84 because that's smaller. So we're going to make the 0.84, which means our limiting reactant is what? Propane or oxygen? Oxygen. Very good. It says using the above problem, how much CO2 will be made? So we're going to take our oxygen flow chart or our oxygen train tracks. We're just going to finish it out. I'm going to multiply times the molar mass of CO2, 32 plus, oh God, I'm having trouble with math today. 44.01. So 45 times 3 times 44.01 divided by 32 times 5. I get 37.13. I might be wrong, but that's what I ended up getting. 37.13 grams of CO2. Yes.
Can you just take the top number?
Number 12. When carbon disulfide burns in the presence of oxygen, sulfur dioxide and carbon dioxide are produced according to the following equation. And I gave you an equation. First thing we should do, is that equation balanced? Let's look at our carbon. 1 on the left, 1 on the right. Is that balanced? Okay. Sulfur, 2 on the left, 2 on the right. Is that balanced? Okay. Oxygen, 6 on the left, 2 plus 4, 6 on the right. Is it balanced? We good. We can move on. All right. Letter A, what is the percent yield for sulfur dioxide if burning 25 grams of carbon disulfide produces 40.5 grams of sulfur dioxide? So we're going to read this question, pick it apart a little bit, and figure out what is what. So produces is an indicator that if you see the word produces or makes or yields, that's an indicator that that is your product. So produces sulfur dioxide. This is sulfur dioxide, SO2. So this 40.5 is going to be called what? My what yield? Called my what yield? Theoretical, actual, or percent? Yeah, my actual yield. So this is my actual yield. And then 25 grams of carbon disulfide. That is going to be my given. Okay. So we have my given and we have our actual yield, which means sulfur dioxide, SO2, which is what my actual yield is. That is going to be my want. So we're going to do a theoretical yield equation to solve for this. And there's no specific equation for theoretical yield. It's just plain out stoichiometry. So we're starting with 25 grams of carbon disulfide. Because I'm starting with grams of carbon disulfide, what do I need to do? put this here as a reminder.
Divide by molar mass.
Yeah, divide by molar mass. Sulfur, I believe, is 32.06. And that's what I'm going to go with. So, okay. Let me double check on that. 32.06, good. So carbon disulfide's molar mass I got is 76.13. Hopefully that's correct because I just did it on my calculator right there. We want sulfur dioxide. What is my coefficient in front of sulfur dioxide? What is it, Vari? In front of sulfur dioxide, SO2. There you go, 2. And in front of CS2, what is it? There it is. All right. So I have my molar mass of my given. I have my mole ratio. What unit is my actual yield given to me in? Grams. So what should my theoretical yield be solved for? What unit? Also grams. So I'm going to need to solve for grams. To solve for grams, in case you forgot, we're going to multiply by the molar mass of what we want. So we're going to solve for SO2. Sulfur is 32.06. Oxygen is 12 or 16. 2 times 16 is 32. 32 plus 32.06 is 64.06. Do we all agree with that? Okay. So 25 times 2 times 64.06 divided by 76.13 gives me 42.07 grams of sulfur dioxide. Am I done? Is that the answer to this question? No, the question really wants to know percent yield. So percent yield is actual over theoretical times 100, correct? So I'm going to take my actual yield, which is 40.5, over my theoretical, which we just calculated to be 42.07. Multiply that times 100. And I get 96.27%. Not too shabby? Okay, let's look at this next one. Using the same chemical equation, so the same one is up here. What's the percent yield of carbon dioxide? So we know we're going to be working with carbon dioxide. If 2.5 moles of oxygen, that's our given, react and give us 32.4 grams of carbon dioxide. So we know that we're going to be working with carbon dioxide. Our given is oxygen, and we have our actual yield. So we're going to do the same thing we did up here, but just with these different numbers. So 2.5 moles of oxygen. I'm trying to solve for carbon dioxide. So in this instance, for this question, carbon dioxide is CO2 right here. CO2. I'm starting with moles. Does anything go underneath moles when I start with moles? No, we just let it be and we move on to the middle. So I'm going to put my coefficient of CO2 in front of that. What's my coefficient for CO2? 1. And my coefficient for O2? 3. Very good. Lastly, my unit for actual yield. What is my unit for my actual yield? Is it moles, liters, grams, particles? Grams. So the last step is I need to multiply times the molar mass of carbon dioxide, which is 44.01. So 2.5 times 44.01 divided by 3 gives us 36.6, we'll say 68 grams of CO2. That is known as my theoretical yield. Theoretical yield. I'm going to take my actual yield, which is 32.4, divide it by my theoretical yield, which is 36.68, and multiply that times 100%. And I get 88.33.